We want to dance, dance, la 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 la, ooh. And I'll spin and dance and I'll even break it down. Wiggy, wiggy. Oh. Look at this new set. We finally made it big time. Ah, yes, I love it, don't you?
Divide, add or subtract, figure what the answer will be. You can do it with a little help from your friends here on TV. Math homework helpers, it's time. Math homework helpers, oh yeah. Math homework helpers, it's time. Math homework helpers, oh yeah.
He is ever so confident in his abilities, he's able to outrun a speeding locomotive. He can clear the Empire State Building in a single leap. He's able to calculate mathematical equations that would boggle the average person's mind. Who is that masked superhero?
Max, what in the world are you doing?
Well, I'm not Max. I'm Maximus the Magnificent.
What? Maximus the Magnificent? You sort of look like Max with a cape and a mask.
Well, I assure you, I'm not that average guy. I'm Maximus the Magnificent.
Max, why do you need to go around pretending you're somebody else?
What?
Yeah, Max, we love you for who you are.
Really?
Yeah. Yes, really, absolutely. You're perfect just the way that you are.
Oh, well, gee, thanks, Mrs. Chess. But I may pretend I'm Maximus the Magnificent just for fun now and then.
I don't know. I think I liked him better as Maximus the Magnificent.
What? Mr. Hobbs, you're quickly becoming my nemesis, you know.
I was just kidding, Max. I think you're perfect just the way you are. Welcome to Math Homework Helpers. I'm Mr. Hobbs from Parkville High School, and this is Miss Chess from Newtown Elementary, and this is Maximus the Magnificent, or Max for short.
Thank you, Mr. Hobbs. As always, the fabulous prize wheel is ready to go. And our special guest spinner today is Ronald from Newtown Elementary School.
We're here to help BCPS students with their math homework. So if you need some help with your math homework, go ahead and give us a call. The number is 410-494-1459. That's 410-494-1459.
There's the number.
Then after we work on your math homework, you get to spin the prize wheel. Okay, who's going to be our very first caller on this fine Wednesday afternoon? Let's go to the phone.
Okay, Mr. Hobbs.
Hello?
Wow. Who's there? Who's that?
This is Eric Sully.
Oh,
Hey, Eric from last year. How you doing?
Hi, Miss Chess.
Good. It's good to hear you. How's middle school going?
So, Eric, you're in 6th grade this year?
Yep.
Fantastic. So, do you like middle school?
Yep.
It's a lot bigger, isn't it?
Yes.
And you're over at Deer Park?
Uh-huh.
They have great water, Mr. Hobbs.
Oh, good.
Yes,
yeah.
they do.
Yeah,
Excellent.
very nice. So, not the first time you heard that joke, huh? So, Eric,
Yes.
what do you got for us today?
I have dividing like a fraction.
Ooh.
All right.
So I'm dividing 8/9, so really 9 divided by 8.
Oh.
All right. So your fraction you said was 8/9?
Uh-huh.
All right. So like that?
Yes.
All right. So what are we going to do with this?
We're going to divide it.
Divide it? Okay. So how do we set this up to divide it? Can I set it up like this, or do I got to change it a little bit?
Okay, hold on. I don't.
All right. How about if I set it up like this?
Yes. So
All right. So now let's start with, can 9 go into 8?
No, so you have to annex a 0. And I got annex for Miss Chess.
Very good. Miss Chess is a great teacher. That's why. All right. So if we bring that 0, can 9 go into 80?
Yes.
And how many times can 9 go into 80?
It can go into 87 times.
7 times? What's 9 times 7?
9 times 7 equals 6. Oh, I mean 8 times. Sorry.
8 times. All right. And what is 9 times 8?
9 times 8 equals 72.
All right. So we put in our 72. So we've got 80 minus 72 is what?
It equals 8.
Equals 8. Okay, so now what do I do?
And now you annex another 0.
Annex another
Listen to that
0.
vocabulary.
Fantastic.
So you've got 9 goes into 80 again. So what am I going to put?
You have to, it's 72, so it's 8 again.
8 again. So am I ever going to get an end to this?
No, so you put a little line over it. I forgot what your chest told me. It's a repeating sign.
Yeah.
Yes, we're going to put the repeating sign over the 8. Is that the line that says that those 8s go on forever?
Yep.
Great job.
Very good, Eric.
Good job. It was good hearing from you, Eric.
You know what, Eric? I think you should get a job on this show, man. You're sounding like a real mathematician out there.
Yep.
Thank you.
Well, guess what? We're not done with you yet. What are we going to do now?
We're going to spin the wheel.
Woo! Let's do it. Spin the wheel.
All right. I have my fingers crossed. First prize of the day.
We got Ronald spinning the wheel over there. He's doing a great job. Here we go. Ronald, spin the wheel. Very good spin. Oh, the finger crossing. Very nice, very nice. And sunglasses. Very cool. We will send you a pair of those sunglasses right out to you. Okay, Eric?
Okay, thank you, Max.
All right,
Bye.
you're welcome. Good hearing from you, buddy.
Bye, Eric.
Okay, bye.
Bye-bye. Oh, man, I miss Eric.
I know. It was good hearing from him.
Yeah, so you used to teach him, right, over
I
in Newtown?
did last year. He graduated from Newtown.
Oh, all our callers are growing up.
I know, so
Oh,
fast.
I'm feeling. Oh, is that pink fur? See, when I get old, I get pink fur.
Oh.
Yeah, it's crazy. All right, our next caller is Joshua from Norwood Elementary. Joshua, are you there?
Yes.
How you doing, buddy?
Josh.
Well, hi.
Hi. How's Mrs. Tarbell doing?
Good.
Good. Tell her we said hi.
Hi. Okay.
All
Very
right.
cool.
What kind of problem do you have for us today, Joshua?
It's 9 times 9.
Okay. What? 9 times 9?
Yeah.
Okay. All right. 9 times 9.
Pretty big one.
That is. Okay. All right. So Joshua, what kind of strategies have you been using to solve these kinds of problems?
Cookie strategy. Cookie strategy.
Cookie strategy?
Yeah.
Sounds tasty.
Oh, have you been doing some skip counting?
Yes.
Okay. All right.
Sounds like he's been doing some eating.
So, do you want maybe, is there a picture we could draw to kind of show this?
Yes.
Okay, what would you like me to draw, Joshua?
9 circles.
Okay, so you'd like me to draw, let's make purple cookies. Okay, so 9 circles. I remember this. This is a really cool way to figure out basic facts if you're unsure. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and one more. So, and I'm going to put a 9 here to show that I have 9 cookies or 9 dots or 9 something. So now I have 9. So do you want to count the cookies again?
We have to put the little dots in the circles. 9 little dots.
Oh, so you want 9 circles with 9 dots?
Yes.
Oh, okay. All right, so here's one group of 9. Okay. So if I make another group,
Every circle should be filled with 9 little dots.
okay, so if I make another group, that will be 18, right?
Okay.
Okay, well, look, just if you can see your TV screen, here's another circle. If I was to put 9 more dots in here, how many would I have total? What's 18 plus 9?
18 plus 9. 27.
27, okay.
Very
And if
good.
I was to go again, how many would there be? If you have 27, how many more? If you add 9 more, how many would that be?
37.
Oh, so close. How about 36?
Oh, 36.
Okay, 36. Now, I'm not going to keep drawing, but if I was to add 9 more, how many would I have?
45.
45. Okay, good. If I was to add one more time, how many would I have? So I have 45. If I was to add 9 more on, how many would I have?
64.
So close. Oh, yes, 54. Sorry. Okay.
Yes.
And then if I was to add one more time, what would I have?
72.
Try one more time. You have 54.
You 54.
It would be 63.
Okay, I'm in 53.
63, okay. And then if I was to add one more time, then it would be 72.
Okay.
Okay, and if then I added 9 more dots on, what would I have?
9 more dots. 72. 81.
81. Okay, now what we just did actually was we skip counted, or we used what's called repeated addition. You did a really good job, Joshua. Okay, so let's count. We skip counted 1, 2, 3, 4, 5, 6, 7, 8, 9 times. We added by 9 times. So 9 times 9 is 81. Good job, Joshua.
Very nice.
Very good.
Yeah.
We worked through that. That can be tough after a while.
Yeah, that was a lot of repeated addition.
That was. And 9s are not easy to go by.
No.
I don't trust 9s all the time. Just like I don't usually trust Mr. Hobbs' ties. But
Sorry.
I have to admit, this tie is very nice. Where did you get this one, Mr. Hobbs?
It was a gift.
Oh, a gift from who?
My mom.
Oh, well, your mother has
Aw.
very good taste. What do you know? You should wear her ties more often.
I do.
I don't want to hear your response on that. Okay, here, let's go. Guess what, Joshua? We're going to do one more thing. What are we going to do?
Spin the wheel.
Woo! Let's go! Spin the wheel! Presents are falling. Wheels are spinning. All right, Ronald. Here we go. Oh, he's the cowboy spinner. And we have... Ooh, the magic math kit. Very cool. We will send that magic math kit right out to you, okay, Josh?
Okay.
Okay, bye. Thanks for calling, buddy. All right. Man, we've had some really nice callers so far.
Yeah.
Let's keep it going. Mulaney, are you there?
Yeah.
Am I saying your name right? Is it Mulaney?
What?
How do you say your name?
Melanie.
Melanie,
Melanie.
okay. I'm sorry, Melanie. How you doing?
Good.
Oh, good. And you're in 3rd grade over at Norwood, right?
Yes.
And you have a money question for us today?
Yes.
Ooh, okay. Go ahead. Tell us what it is.
Horace purchased a book for $2.95. He paid with a $5 bill. How much change will he receive?
Ooh, a change problem.
All right, so we have $2.95, and we're paying with $5. All right, so do you know how we're going to start with this problem?
I don't know.
All right, well, let's look at some money here. So if I've got, let's see, $2.95. So we've got $1. All right, so we can make $2. All right, so now I've got $2. So now we need 95 cents. So there's, let's see, 1/4. We need 2 more of those. Okay, so there's 275, 285, and 295. All right, so now we want to try to get this to be this $5 bill over here. Okay, so how many more dollars do I need to make to get a $5 bill?
$3 and something?
I would need 3 more dollars. And of course, we've now killed the machine.
Ah!
All right, so 3 more dollars. If I have 95, what would I have to add to the 295 to make it another dollar?
I'll be down here fixing it. I'll be right back.
Okay. If we had 295 and we wanted to get to $1, which would be 100, how would I go from 95 to 100?
A nickel.
A nickel. All right, so that's 5 cents right there. And now I want to add 5 cents would give me to $3. From $3 to $5, I need how much more?
2 more dollars.
2 more dollars. So if we take $2.05, that's how much change you get.
$2.95. $2.05.
Yes.
Yes.
All right?
Okay.
Sorry we couldn't show it to you.
It looks, I know it would look good.
Yes, it would look wonderful.
It would look as good as Mr. Hub's tie.
Thank you.
Yes. All right, well, we're not done with you yet, Melanie. What do we do now, kiddo?
Spin the wheel.
Yeah, let's do it. We got that working. Here we go. Let's spin the wheel. Woo! Oh, nice hat, Ronald. Here we go. And it is, ooh, the flashlight. Very cool. We will send that flashlight right out to you, Melanie. Melanie, thank you so very much for calling. And call back soon, okay?
Okay.
Okie dokies. All right. Solomon, are you there? Solomon? Hello? Is anyone on the phone?
Solomon.
Whoa! Oh, you scared me. How you doing?
Good.
And you're calling from Bedford Elementary?
Yeah.
Very nice. Did you have a good day today?
Yeah.
And you're in 4th grade?
Okay.
Yeah.
Okay. Well, that's very nice.
So how is Bedford Elementary? Did you have a good day today?
Yes, I did.
Good, good. Did you get to go outside for recess today? It was such a pretty day.
Did you go outside for recess? No.
No.
No!
Oh,
Oh, no!
that's a shame.
Oh!
All right, well, it looks like we're ready to solve your problem, Solomon. So what kind of problem do you have for us today?
It's a word problem.
Ah!
Ooh, I like word problems. Okay, all right, let's hear it.
What is the volume of a cube if each side is 1 inch?
What is the volume of a cube if each side is 1 inch?
Yes.
Okay, all right.
Sounds noisy.
It just has 1 inch. Okay, all right. So, let's see here. Do we have a cube? No, we don't have a cube. Okay, all right. Well, Miss Chess is going to do her best to actually draw a cube. Okay.
Here we go.
All right. So, and when I think cube, I kind of think maybe something that would look like a number cube. Have you ever used number cubes? Do you or dice at school? Okay, so I'm going to draw something that kind of looks like a number cube. Okay. All right.
Very nice. Miss
Now,
Jess.
so what do you know about volume?
I don't know.
Okay. Well, volume is what the amount that a figure can hold or the amount of space inside of a figure. Okay. So if I look at this, and I really like working with cubes because cubes are like squares. And what do you know about a square? There's something very important about a square that makes a square a square.
It has equal sides.
It has 4 equal sides. Well, a cube has actually 6 equal sides that are all squares. That's what makes a cube a cube. A cube is made up of squares, okay? So, to find volume, what you have to do is you have to look at how high and how wide and how deep something is, okay? So, if I have a cube that has a volume of 1 inch, okay, or what?
The sides of 1 inch, right?
Yeah, sides of 1 inch. So, how tall would that cube be? How tall would it be? If the sides are 1 inch.
I don't know.
Well, it would be 1 inch high. Okay? It's 1 inch high. All right? Now, if it's a square, and we know that it's made up of squares, if it's 1 inch high, how wide is it going to be?
1 inch.
1 inch. Good.
There you go.
Okay. And then, how deep is it going to be on the other side? If it's 1 inch high and 1 inch wide, how long is it going to be?
1 inch.
1 inch, okay. So to find volume, you have to multiply the length, which is 1 inch, times the width, which was 1 inch, times the height, which was 1 inch. And what is, I'm not trying to trick you, Solomon, what is 1 times 1 times 1?
1.
1. So the volume is 1 inch, and you're going to put a little 3 next to your inch sign to show that it's a cube. Okay, so 1 inch cubed, or 1, if you wanted to write it out, 1 cubic inch. Okay?
Very cool.
All right.
That's good to know, like if I'm measuring how big my TV is or something.
Yes.
You know, 25 feet by 25 feet by 25 feet.
Yeah.
That's a very big TV,
That's a
Max.
huge TV.
Oh, that's just the little one I keep in my glove box.
Oh,
okay.
wow, wow.
Yeah, big car. All right, well, guess what, Solomon? You know what we do now?
Spin the wheel.
You got it,
All
buddy. Let's
right.
do it. Here come the presents. Here comes that wheel. Here comes Ronald. Here we go. Whoa.
Whoa, oh.
All righty. And it is all right.
Ooh.
It is the MP3 player. Very cool. Solomon, we are going to send that MP3 player right out to your school for you, okay?
Congratulations, Solomon.
Yeah. You're welcome. Thanks for calling. Okie dokies. Our next caller is Sydney from Edgemere Elementary School. Sydney, are you there?
Yeah.
How are you, kiddo?
Good.
Did you have a good day?
Yes.
And you're in, let's see, first grade?
4th.
Oh, second grade?
Mm.
Just kidding. So what are you doing over there in 4th grade these days? What are you learning about in math?
In math, we're learning about solid and plane figures.
Ooh, solid. Cool. All right, well, go ahead. Tell us what your question is.
The question is, how many faces, edges, vertices does a cube have?
Okay.
Oh, do
Cube.
you want to go back to what we did before?
You
All
just
right.
drew a very nice cube.
This day brought to you by Cubes.
Yes. So Miss Chess has a very nice cube that she drew here. So we're looking for faces, vertices, and edges, right?
Yes.
All right, so what is a face?
A face is when, like, where it's the front of the object.
Okay. So for faces, we're talking about how many fronts does that object have. All right, so let's look. I've got this one right here, right? The front of the cube. So if we have the front and the back, how many is that?
2.
2, all right. And then if I add in top and bottom, what's that?
2.
Okay, so I have 2 and 2, and then how about how many sides do we have?
2.
2, so if I have 2 and 2 and 2, that's how many total?
6.
6, very good. All right, so faces, so we're one step down. So next time you said we had the what, the vertices?
Yeah.
What is a vertices?
A vertice is when 3 or more edges meet.
Okay, so how many, so we're talking about how many corners, right?
Yeah.
Yep.
All right, so let's look. If I have a corner here and a corner here, so I'm just going to put a dot everywhere we have a
That's a
corner.
really good strategy. I like that strategy.
Thank you. So how many dots did I draw?
8.
All right, we have 8 vertices. And then, what was the last one? Edges?
Yes.
Edges. So what are the edges?
The edges are, like the side of a face.
It's actually where 2 faces would meet. An edge is where 3 or more meet, but vertices are 3 or more would meet. But an edge is where 2 faces meet,
Right.
almost like a line.
So it's where our lines are. So if we just take here and we're going to highlight all of our lines, just make this a nice colorful drawing. So how many times am I highlighting here? That's what we're looking for. All right, so did we see how many times did we highlight?
10.
We have 10. Very good. All right, let's get back on our pen, and we have 10. All right, is that all we need to know about a cube?
Yes.
Awesome.
All right. Good job.
Great job.
Hey, speaking of faces,
What?
you probably don't know who I am right now.
Are you Maximus the Magnificent?
No, that's me!
Ah,
I am Maximus the Oh, wait, you just said that.
I did.
Yes, but that's okay, because you need to get the word out there. that I will help anyone with homework, any math problem they will ever have. Their math problem is my math problem, and I will solve it until it is not a problem anymore.
Good. So do you want to solve the next one?
Not yet.
Okay.
We must first spin the wheel. Oh, my mask. And it is the backpack, the very styling backpack. Very cool. All right, Cindy, we'll send that backpack right out to you, okay?
Okay.
Hey, so Mr. Hobbs, who were you talking to just a minute ago?
Maximus the Magnificent.
He was here?
He
was
was.
here in our
He
studio?
was.
You missed
Yep.
it. You missed it. He was here and you missed it.
I'm one of his biggest fans. He's extremely good looking. You know that, right, Mr. Hobbs?
I've heard.
Yes.
I've heard.
He's
Miss
very
Jess,
handsome.
you know. I mean,
He
he's
is
like,
so handsome.
You see
Oh.
that guy, and it's like the fur is just flying. You know what I'm saying?
Yes,
Yep.
yes.
Woo! Well, let's move on. Our next caller is Nick from Halthorpe Elementary School. Nick, are you there?
Yeah.
How you doing, buddy?
Good.
All right. So, did you get hurt today?
No.
Did you break a leg or an arm?
No.
Well, then why are you calling about fractions? What?
Sorry.
Did I miss
Sorry.
something here? What's going on? Fractions, right?
Yep.
Yeah.
Are you okay, Nick?
Yeah.
Okay.
No.
What kind of fractions do you have for us today?
I need to know if 6/30 is closest to 0, 1/2, or 1.
Oh, I love fractions, and I love
mathematical fractions.
mathematical fractions.
Mr. Hobbs, where were you on that one? Come on, man, help me out.
Sorry.
All right, well, I'm going to start actually. Let's draw a number line. Okay, I love to look at fractions on a number line. Okay.
Okay.
All right, and I'm going to make my number line.
Ooh, that's a nice line
Actually,
there, Miss
no, I
Jess.
don't want to do that because I want it to go on forever. Okay, all right. All right, so I'm going to go this way, and I'm going to go this way.
It's a very steady line.
And I'm going to start my number line at 0, but it could go on with the negative numbers. I'm going to end it at 1. Now, what fraction, this is one of my favorite fractions, because if you know half, you'll go far. Where would you put half on a fraction, on a number line that goes from 0 to 1? Where would you put it?
In the middle.
Right in the middle. All right, good job. So now we have our number line ready to go. Okay, and what fraction are we kind of looking at today?
6/30.
6/30. Okay, all right. So I'm going to write 6/30 over here.
Is it already 6:30? So I got to get home.
I know, no, you have time. You have time.
Oh, okay.
All right, so 6/30. Well, what do you know about 30 and half? Like if you had 30 M&Ms and you wanted to give someone half, how many M&Ms would you give them?
15.
15, good, because 15 is half of 30, right? So what I'm going to do is, on my number line, underneath the half, I'm going to write 15/30, because 15/30 is half, or half and 15/30 are equivalent fractions. They may look a little bit different, but their value is the same, okay?
Okay.
All right, so now I have 6/30. Okay, so let's think about this. If you have 6/30, now if you had a big bag of M&Ms that had 30 M&Ms in it, and you gave someone 6 of those M&Ms, are you giving them close to the whole bag of M&Ms? Are you giving them close to half of the M&Ms? Are you giving them close to, or really not that many of the M&Ms at all? What do you think?
0.
Yeah, you're giving them close to 0, because really on our number line, 6/30 would be about here. So I would say that 6/30 is approximately 0.
Okay.
Okay? All right, or it's closer to 0. Okay? That was really good. I enjoyed talking about that. I love fractions on a number line,
Yeah, I
Nick.
tell you, that line really makes it clear. You know, it really helps you to see what's going on.
Yep.
Very cool. All righty. Well, you know what we do now, right, Nick?
No.
Oh. Oh, great.
Are you a first-time caller,
What are we
Nick?
supposed to do now, guys? I was hoping he'd answer that for me.
I think we spin the wheel for
Oh,
Nick.
yeah, I forgot. We're going to spin the wheel. Let's do it. Spin the wheel. Woo! Let's hear it, Mr. Hobbs. Woo!
Woo!
Miss Jess.
Woo!
Miss Jess is better, Mr. Hobbs.
Sorry.
She usually is better.
Yeah.
And It's a t-shirt. Very cool. Nick, we're going to send that t-shirt right out to you, okay?
Okay.
All right, thanks for calling, buddy.
Bye, Nick.
Bye.
Man, we have been a busy group of people today.
Yes, we
Yeah.
have.
Well,
yes,
I'm a
we
puppet,
have.
so you're the people.
Yeah.
Moving on, Jordan from Pikesville Middle School. Are you there?
Yeah.
Whoa! What's going on, Jordan?
Nothing.
So you're in 7th grade this year, right?
Yeah.
Woo! What high school are you going to go to?
Pikesville
Oh, wait, that's where you are now.
Middle School.
You're going to go to Pikesville Middle School after you go to Pikesville Middle School?
No, I'm in high school.
Oh, you're in high school now?
No, I'm going to High School.
Oh. Oh, there's 2 Pikesvilles. I got it. Okay.
Yeah.
Sorry about that. So
Wow, there's
anyway.
a little smoke coming off of you there.
Huh?
You're
What?
thinking really hard.
Oh, I am thinking hard. Which is weird because I don't even know what that means. Okay. So, Jordan, what is your question for us today?
2 and 5/10 plus 8 and 9/10.
Ooh.
So 2 and 5/10 plus, what was the second one?
8 and 9/10.
8 and 9/10. All
Yeah.
right. So we got to add these together. So how do I add these together?
You do 2 plus 9.
I do 2 plus 9.
Yeah.
All right, well, let's look. Is the 2 here and my 9, are they in the same place?
No.
No, so can I add things together that aren't in the same place?
Yes.
I mean, I can't add them together. They're not in that same place. So what is in the same place as the 2?
Plus 5.
Right, the 5 and the 9 are in the same place. Good job. So what is 9 plus 5?
9, 10, 11, 12, 13, 14.
Good.
14. So I've got 14 over 10. Can I have a fraction that's 14 over 10?
Yes.
I can, but do we really like that? I mean, if we're talking mixed numbers up here, do we want this kind of fraction down here, that improper fraction?
Oh, no, 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 no.
No. Nothing improper. So what do I do to make this not an improper fraction?
You multiply,
Not multiply.
divide.
Well, sort of. If I have 10 on the bottom, I need to take 10 out of this top. So if I take 10 away from that 14, what do I have?
5, 4.
4. So I'm going to have 4 out of 10. Well, what happened to the rest of them?
They become a whole.
They
Very
become a
good,
whole.
Jordan.
Good job.
Good job.
Because I've got that 10 over 10, which is just 1. So now I can add the things that are in that position. So the 1, the 2, and what else is the same?
8.
The 8. So what is 8 plus 2 plus 1?
12,
Not 12. Close.
13,
No, 8 plus 2 is what?
10,
Plus 1 is?
11.
11. Good job. So there is your final answer. 11 and 4/10.
Good job,
Very
Jordan.
nice.
Thank you.
You're welcome.
Good job.
Hey, guys, check it out. I'm the headless math course man.
Wow.
Oh.
Huh?
Very
Yeah.
good.
Yeah.
Yeah.
I don't want to get in my head. I don't want to get ahead of myself here on this joke, but I don't think I'll ever be the head of a major corporation.
Nope.
No,
Nope.
I don't think so either.
Yep. Better get my head checked.
Yep.
So
Yeah.
now my eyeball is showing.
Here.
Ah! Now I am spooky again.
Ah!
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 There's my eyes. Ah!
No! Oh!
It's kind of nicer this way.
Yeah.
What?
There.
That's your arms. Alrighty.
Let's spin the wheel.
Jordan, let's spin the wheel. Here we go. Woo! All right, Ronald, take it away. Oh my God!
Oh,
Look
wow.
at that! And it is the backpack again. Very cool. All right, that's our second backpack today. Those things
know.
are very fashionable, you know.
They are.
I love the backpack.
Yeah, Jordan, we're gonna send that backpack right out to you. Okay?
Okay.
Thanks for
thank
calling. Bye bye.
you. Bye.
Bye.
All right, let's move on. Harley, are you there?
Yes.
How are you?
Good.
So you're calling from Battle Grove Elementary School, right?
Yeah.
What a cool name for school. And you have a question for us today about multiplication.
Mhm.
Okie dokies. Let's hear it.
12 times 24.
Ooh.
12 times 24.
12 times 24. So what strategies have you been working on in school, Harley?
We've been working on multiplication.
Okay, well, have you been using the standard algorithm where maybe you multiply and then add, or have you been breaking numbers apart? What have you been doing?
We've been doing the thing that it's the chart and you put 12 on the top and 24 at the bottom.
Okay, so you've been using what's called the standard algorithm, right?
Yes.
Okay, well, I actually have mine 24 times 12. Is that okay that I have those factors that way?
Yes.
Okay, because it doesn't matter because of the commutative property of multiplication. No matter what order you multiply those factors in, you're still going to get a product that's the same. Okay, so really what I'm doing is I'm actually going to multiply 24 times 2 first. So do you want to help me out?
Yes.
Okay. All right, so where do I start?
You start, you do 2 times 2.
Oh, actually, I'm going to put some labels up here. This is my 10s and this is my 1s. I actually want to start, I want to multiply 2 times my 1s first. So what's 2 times 4?
I think he thinks you're adding.
Oh, 2 times 4.
2 times 4 is 8.
There we go.
Okay. And then 2 times 2 is?
4.
Okay. All right. So I know that 24 times 2 is 48. I'm just going to make that note here so I can keep track of it. Okay. So I just multiplied 24 times 2. So now I'm actually going to multiply 24 times 10 because this 1 is in the tens place. So it's not really 1, it's
0.
It's
Wait,
10. Well, it's
100.
10. Okay.
10.
So what would you like me to do next, Harley?
I would do 240.
Oh, I like how you did that. Okay. Because you know that 10 times 24 is going to be 240. You know your powers of 10. Good job. Nice work. That was really easy, Harley. Okay, and I'm just going to write my partial product here for this 240 that you just gave me. Okay, so really we multiplied 24 times 2 and then 24 times 10. I love how you did that in your head. So now we have what's called partial products, okay? And we're going to add those up and see how I kept my place values. My 1s are lined up with my 1s and my 10s are lined up with my 10s, and then here's my 200 here. So can you help me add these partial products up? What's 8 plus 0?
8 plus 0 is 8.
Okay. And 4 plus 4?
8.
And 2 plus 0 is?
2.
2. All right. So your product is 288. You did a really good job with that, Harley.
Yeah. Very good way to put it together. And once you get used to it, it gets a lot easier, I think, too. Very good. And you said the word product. Why didn't you say answer, Miss Chess?
Well, because the product is an answer of a multiplication problem.
Oh, that's right. Of course. If you're multiplying, you always call your answer the product.
Could you do that funny dance?
The dance? Oh, yes. Did you hear that, Mr. Hubbs?
I did.
I heard it, Mr. Quest.
The first one to ask for it all day. Well, I tell you what, Harley, you got it. Here we go. Ready? This is my special dance for everyone who doesn't know. Okay? And if you don't know, that's terrible. Anyway, here we go. Woo! There we go. Fixes the fur every time. All right, Harley, it's time to spin the wheel. Let's go. All right, Ronald, here we go. Time. Wow, there he is. And it is, very cool, the T-shirt. Very nice. You look very styling in that, buddy. Harley, we'll send that T-shirt right out to you, okay?
Can I say one more thing?
Yeah, sure, go ahead.
You rock.
Woo! Cool. Oh, wait, there's the T-shirt.
There's the T-shirt.
All
Nice.
right.
Very cool. What's in that? Oh, look, and I'm on the T-shirt.
You are.
Oh, Mr. Hobbs, I don't see you there. Where are you on the T-shirt?
I'm right here. See?
Oh, there you are. Wait a minute. All right. Harley, we'll send that right out to you. Take care, buddy. All right, Varai, are you there? Mariah?
Hello?
How are you?
I'm good.
All right. How's Deer Park Middle School going?
Good.
All right, very good. So you have a question for us about triangles, huh?
Yes.
Okay, go ahead. Tell us what it is.
I have to find the area of a triangle.
All right.
Okay.
Okay.
So what do we know about the triangle?
There's 3 sides.
3 sides.
All right.
All right. Do we know the measurements of any of those 3 sides?
4 inches and 2 inches.
4 inches and 2 inches. So chances are your triangle doesn't look like this one, does it?
No.
No, your triangle probably, let's see if we can get rid of this triangle. Your triangle looks more like this one, doesn't it?
Yeah.
All right, and they said that this is 4 inches and this is 2 inches.
And the 4 goes on the base.
Oh, we switched them.
I'm not smiling. I'm not laughing.
All right, so 2 here and 4 here.
Yeah.
All right, so how do I find the area of a triangle?
You have to do the formula, base times height divided by 2.
All right, so my area is going to equal the base times the height divided by 2. All right, so which one's the base, which one's the height?
The base is 4, height is 2.
All right, so I'm going to plug my numbers in. So 4 times 2 over 2. So what is 4 times 2?
8.
8. So bring that down here. So we have 8 over 2. What is 8 divided by 2?
4.
4. Now, did we have any units here? Did they tell us, is that 2 inches, 4 inches?
4 inches.
4 inches. So when we're talking about area, then this becomes inches what?
Huh?
When we're talking about area, our inches become what?
4 inches squared.
4 inches squared. Great job. It's really good. You did a great job with that one.
Good job.
Yeah.
Thank you.
Do-do-do. Mariah! Mariah, how are you?
Good.
I am Maximus. Maximus, and I am now going to demonstrate one of my amazing abilities. I can catch kumquats in my mouth. Here we go. Ow! Oh! Ow! Wait! Oh! Oh! Wait! I can't! Ow! Oh! Spin the wheel! Just spin the wheel! Just ow! All right, there it is, and it is. All right, a
Ooh,
water
water
bottle. Very
bottle.
cool. We're going to send that water bottle right out to you, Brian. Thank you very much for calling.
All right. Bye, Mr. S. Bye, Miss Max.
Bye.
Bye.
Take care. Whew, did you guys see him? He was
did.
here just a second ago.
Yep.
Yes, we
Wow.
saw him.
Yeah.
Yes.
Yeah, he's not a very good catch.
Yeah, he's,
What's that?
He's not a very good catch.
Yeah, not very good
I
catch.
I'm not making out what you're saying there. Let's move on. Allie, are you there? Allie,
Yep.
how you doing?
Good.
How's Newtown?
Yep.
You having a good year?
Yes.
Excellent. What is your question for us today?
12 and 45 plus 3 and 56.
Is that a decimal, Ali?
Yes.
Okay. All right. Okay. All right. So if you look at your TV screen, do I have all my decimal places lined up?
Yes.
Okay. Can you read that decimal to me one more time, the top add end?
No.
Yes, you can, Ali. Read the decimal for me one more time. 12 and what is this?
3.56.
Right, 3 and 56 hundredths, right?
Yeah.
Okay, can you read the top one?
Yeah.
Okay, read it for me.
12.45.
Or 12 and 45 hundredths. All right. So where do you want to start? Do you want to start in the tenths place, the hundredths place, the tens, the ones? Where do you want to start?
The hundredths.
The hundredths, okay. So what's 5 plus 6?
11.
Okay. Regroup the 1. Okay. Now what?
You regroup the 1.
Okay. So let's add up the tenths place. 1 plus 4 plus 5?
10.
Okay. I'm going to regroup my 1 here into the ones place, that 10 tenths. Okay, so 1 plus 2 plus 3 is?
6.
6. Okay. And then 1 plus no tens, 110 plus no tens is just 110. All right, so if you look at your TV screen, are you okay with that sum that we got?
Excuse me?
Can you see your TV screen, Ollie?
Yeah.
Okay, are you okay with what's written on the screen?
Yeah.
You sure?
Is it missing something,
Is it
Allie?
missing something?
No.
I think we're missing a
I think
decimal
there's a
point.
point to miss. Oh, yes.
Yeah, there it is. Okay, so 16 and 1/100th.
16.
There you go.
17.
Nope, nope.
Nope.
Your
What?
sum is 16 and 100th. It's okay, buddy.
Allie, you got to make sure. Wait a minute. You're in Newtown, right?
Yeah.
Okay, well, tomorrow you can definitely talk to Miss Chess about this one again. But here, go back to the screen real quick. Let's show him one more time. So let's talk about what happens on the other side of that decimal point. What's the 0 place?
The 0. The
That's yours in the what place?
It's in the thousands.
Okay. All right, this is the tenths place. And then what's place is the 1 in? If this is the tenths, what's the 1 in?
Oh, it's in the tens.
Okay, the 0's in the tenths, so what about the 1?
The 1 is in the tens.
It's in the hundredths.
So you have the 10th place, and then next to the 10th place is the 100th place.
Oh.
Okay.
So that's why she's saying hundredths at the end. It's actually quite a very cool word, hundredths.
Hundredths.
Hundredths. Hundredths of people. Come see Maximus. Hundredths of people everywhere. Okay, moving on. Let's spin the wheel for Ollie. Woo! Wheels are falling, wheels are spinning. All right, Ronald. Oh, he's got a baseball bat.
Oh, wow.
Whoa! Very cool! Didn't see the hand in that one. Oh, it's the magic
Magic
math
Math
kit.
Kit.
Very cool. We will send that magic math kit right out to you, okay, Allie?
Okay.
All right, thanks for calling, buddy. Very nicely done.
Bye. See you tomorrow.
Very cool.
Bye.
That can be confusing sometimes,
Yes.
those places.
Yes, it can.
Yep,
yes,
yep,
it
yep.
can.
All right. Amira, are you there?
Yes,
How are ya?
it's Amira.
Amira, okay, I'm sorry. Amira. I'm going to say it 3 times. Amira, Amira, Amira. Okay, now I know it. I'm
Okay.
good to go. So, Amira, you're in 4th grade, right?
Yes,
And you're calling from Padonia Elementary School?
yes.
Oh, very nice. I do some shopping over at that Target every once in a while next door.
Mm,
Yep, it's very cool. All right, so anyway, what is your question for us today?
My question says find the quotient.
Ooh, quotient.
Ooh.
The numbers are 300 divided by 6.
300 divided by, did you say 6?
I think so.
Yes.
All right, so 300 divided by 6. So quotient,
Okay.
what's quotient mean?
Quotient means
Isn't it like croissant?
Not quite.
No.
Do we know what's a quotient?
a quotient is I forgot.
Quotient, that's just what we call the answer to a division problem. All right, so let's look. Can we do, if I have 3, can I take 6 out of 3?
Yes.
If I only have 3 of something, I can take and break it up into groups of 6?
No.
No, so I'm going to put a little x there. I can't do that one. Let's see, now if I have 30, can I make 30 into groups of 6?
Yes.
How many?
5.
5.
Way
Good
to
job.
go.
And what is 5 times 6?
30.
30. All right, so what do I do now?
Subtract.
Subtract. 30 minus 30 is
0.
0. All right, so now I got to bring down my other 0. So If I have 0 of something, how many groups of 6 can I make out of 0?
0.
0. So am I all done?
Yes.
I am all done. So the quotient equals 50. Good job.
So we say quotient when?
What did you say?
When do we say quotient? What kind of problem are we doing?
Quotient problem.
But it's a what? Quotient's the answer to a...
Problem.
What kind of problem?
Quotient problem.
What did we just do when we had that 300 and the 6? We
Divided.
divided. Very good.
So we got quotient for division and then product for multiplication, right?
Yep.
Very good. And then addition is sum, right? And then subtraction is difference.
Yes.
Very good.
Hey, look at that!
Yeah.
I'm getting there. Alrighty. Well, let's spin the wheel. What do you say?
Spin the wheel.
Yeah, let's do it. Let's spin the wheel. Spin the wheel. All right. Come on, Ronald. Let's see what you... Wow.
Oh, look at Ronald catch.
Holy moly, he's catching all his kumquats. All right, here we go. And it is... the desk stuffer. Very cool. We will send that desk stuffer right out to you. Thanks for calling.
Okay, bye.
Bye-bye. Yeah, we've had some great callers today.
Yeah, very nice.
We have.
All right, Jalen, are you there? Jalen?
Yes.
Oh!
Oh,
Sorry, you
Max.
scared me.
Oh, okay.
Jalen, you're calling from Sussex Elementary School, right?
Uh-huh.
Oh, very cool. So, what is your question for us today?
35 times 12.
Ooh, 35 times
Product
12.
problem.
Another product. Okay. And how have you been multiplying at Sussex Elementary School? What kind of strategies have you been using, Jalen?
We started using break apart on multiplication.
Oh, break apart. Okay. So what numbers would you like me to break apart? Do you want me to break apart the 35 or do you want me to break apart the 12? It's your pick.
The 35 or the 12? The 12.
We do the 12? Okay. So if I was to break 35 or 12 into two numbers that are really easy to multiply by, what two numbers that when you add them up equal 12?
6.
Oh, you want to do 6? Okay, 6 plus 6, we can do that. Okay. And the reason we're choosing 6 plus 6 is because 6 plus 6 is 12, right? Okay. All right. So let's multiply 35 times 6. That's kind of an easy one to do. Okay. All right. So what's 35 or what's 5 times 6?
30.
30. And regroup the 3. All right. Now what do I do, Jalen?
18.
18 plus the 3 tens is? 18 plus
21.
the 21. Okay. Now, I like that you picked 6 plus 6 because if I do 35 times 6 again, I already know that that's going to be 210. So we have two partial products here. What should we do to these two partial products, this 210 and then the second 210? Should
Add them together.
Add them together. Excellent use of the break apart strategy. Okay. And 210 plus 210 is?
420.
420. Way to go, Jalen. You really know your strategies and your basic facts.
Very
Good job.
cool.
Wow. Wowza.
And that's a fact. Yeah? Yeah? You know what I mean?
Yep.
Get that? Alrighty. Jalen, it's time to spin the wheel. Here we go. Whoop, there comes the present. There's the spinning wheel. Alrighty. What's the guy with that basket? Whoa!
Whoa.
Oh, look at that! He's catching kumquats!
Wow.
Holy moly! 3, 4! Woo! Very cool. And there's the spin. All right, Ronald, what do we got? Oh, another cool pair. I can't talk anymore. Of sunglasses. We will send those pair of sunglasses right out to you, okay, kiddo?
Uh-huh.
All right. Thanks for
Bye.
calling. All right. Brianna, are you there? Brianna?
Hi, Brianna.
Hey, you're calling from Cockeysville Middle School. How are you?
Good.
All right. So you have a question for us about negative numbers?
Mm-hmm.
Okay, go ahead. Tell us what it is.
It says negative 21 plus 36.
Negative 21 plus 36.
That's a negative.
All right. So what do we do for negative 21 plus 36? When we have a negative number, that's really just another way of saying what? Do we know?
I forgot.
Okay, negative is really just another way of saying minus. See how it kind of looks like a minus sign?
Yeah.
So if I do 36 minus 21, okay, so what is 6 minus 1?
6 minus 1.
Uh-huh. If I have 6 and I take 1 away from it, I only have
5.
5. Very good. And now 3 minus 2 is?
1.
1. Very good. So my final answer, negative 21 plus 36, which we say is the same thing as 36 minus 21, just equals 15. Good job.
Right.
Very nice, Brianna. Alrighty, so we got a positive experience out of that
Yes.
negative problem, huh?
We did.
Yeah?
Yes.
Yeah? With the pot. Okay, let's spin the wheel. Here we go. Spin it for Brianna Ronald. Wow!
Whoa, it's Ronald the Magnificent.
Ronald the Magnificent. And it is another T-shirt.
Ooh.
Man, we're gonna have to go and get some more T-shirts. We're probably gonna run low after today.
Yeah.
All right, Brianna, we will send that T-shirt right out to you, okay?
Okay.
All right, thanks for
Thank you.
calling.
Well,
Bye.
Maximus,
Yeah.
another show's come to an end.
Oh, well, congratulations to all of our prize wheel winners, and thanks to our guest spinner, Ronald from Newtown Elementary. Oh, there he is.
There he is. Remember, kids, we do re-air this episode of Math Homework Helpers every day of the week. So be sure to tell everybody to watch. From all of us here at Math Homework Helpers, we'll see you next week.
Only here on BCPS-TV, Comcast 73, and Verizon 34.
Bye, everybody.